Who's able to tell me what's the goal of equation solving? What's the whole point of solving an equation? To answer for what? Like on number one, what are we trying to figure out? What's that? Yeah, we're trying to figure out the value of the variable, right? What does m equal? So that's the whole point of equation solving, is to identify the value of the variable. So far, we haven't really done that yet. We were told at one point what the variable was equal to, and we substituted it and we solved when we were evaluating expressions. And we worked with the distributive property and combining like terms, in which we just put things together that could be put together. And today we're going to be moving on to actually figure out what that value of the variable is equal to. And in order to figure out what a variable is equal to, we basically have to unpack everything to get the variable by itself, because unless this is isolated, we call it isolating the variable. Unless this variable is by itself, it's going to be with a whole bunch of other stuff, numbers and expressions and things like that. And so the whole idea here is to make this equation end up saying m equals and then have a number that it's equal to. And so we have to basically undo everything that's happening to the variable. So for example, if we knew what m was equal to, if we actually knew what m was, what would we do with it? What's the operation here next to m? Yeah, if we knew what m was, which we don't yet, but if we knew what it was, all we would have to do is add 12 to it. And that would just be the value of m plus 12, because that's all this is. If we look at the left side, this expression, that's just addition, right? We're adding two numbers together. If it was 1, it would be 1 plus 12. It's not 1, but if it was, that's what we would do. And so what we have to do is we basically have to work backwards and undo what's happening to the variable in order to get the variable by itself. So just going to put a note off to the side here, and I'm going to say undo the operation with the variable. So whatever is happening with this variable, we're going to undo that by doing the opposite. We do the opposite operation to isolate the variable, to get it by itself. And when we're dealing with equations, can we agree that everything on the left here is the same as everything on the right? Like the m plus 12 is the same as 10. Can we agree on that? Because there's an equal sign here. Equals means what? Equals means the same. So we're being told that these two things added together is the same as 10. And so if we have these two things on each side that are the same as each other, if we do something to, I'm going to call this the left side of the equation, that would be m plus 12. If we do something to the left side of the equation over here with the m plus 12, what would we have to do on the right-hand side to keep it equal? Anybody know? The same thing, yeah. Some of you might have seen this before, but there's something that happens a lot in math where teachers will use different analogies, and an equation is kind of like a scale. You guys seen scales in science where you have to keep it balanced, right? So this side is the same weight as this side, it equals each other. So if you've got yourself this scale, and right, this side over here has to be the same weight as that side if it's going to be balanced. So if I were to, let's say this is 5 pounds over here. Let's see, 5 pounds on this side, and then 5 pounds on this side. So it's balanced, right? If I were to take away 1 pound from this side, what would I have to do over here to keep it balanced? Same thing, exactly. I have to take away the same amount in order to keep that scale balanced. That's what an equation is like. An equation is like a scale, it's like a balance, where we want to make sure that this side of the equation is always equal to that side of the equation. And so if we do something over here, we have to do the exact same thing over here. Because this equal sign means those two things must be the same, always. If they're not the same, it's no longer an equation. It's an inequality, right? So we need to make sure that with equations, we always keep things exactly the same on both sides in terms of what we do to the equation. So first thing I'm going to show you, and you've probably seen this before as well, is I always draw a line, a vertical line right down the middle of my equal sign. And that's because I want to be able to see where the left side of my equation is and where the right side of my equation is the whole way through. Because as we move things around, one side of the equation, one expression might get larger than the other side in terms of what's there, but the values have to stay the same. So if I keep my equal sign in the middle, it just visually makes it a little bit easier to see what's going on. All right, now, if I have whatever number plus 12, and that's equal to 10, if I want to undo this operation, what's the opposite of adding? Subtracting. All right, so if we're adding 12 to m, I want to get m by itself, so I want to take away 12 from this side right here. So I'm going to subtract 12. Whatever's happening on the side with the variable basically tells us what we need to do to solve the equation. So if I have a plus 12 here, I need to get rid of that 12 because all I want on this side is m, because I'm trying to get the variable by itself. But just like over here with this little diagram, that little sketch over there, if I take away 12 from one side, I have to take away 12 from this side as well. And this might seem really basic and you're like, yeah, I've seen this before, and which is great. If you do, if you know this, awesome. So if I take away 12 from this side of the equation, can I take away 12 from m? Is that something I'm allowed to do? I see Elle shaking her head. No, why not, Elle? Well, yeah, because, and I think maybe I heard you correctly, but m and 12, we can't subtract those, we can't put those together because these are not like terms, right? This has a variable and that doesn't, so they don't go together, but I can take away 12 from 12. And what is 12 minus 12? 0. So 12 minus 12 is 0, which means that the 12s cancel out. They go away because there's no longer anything with a regular number there, right? Our constant term, the regular number 12, is now gone because we literally took it away. It's out of it. And so all we have left over here is m. The regular numbers are gone. And on the left-hand side of the equation, we're left with our variable m, which is exactly what we wanted. We wanted m to be all by itself right here. Now we need to go back to the right-hand side, and we need to remember a little bit about adding and subtracting integers, or if you want to, feel free to grab a calculator. But we're going to do the math on this side too. 10 minus 12. What do we get? -2, exactly. And so we're left with an answer, and the answer says m is equal to -2. And so for a one-step equation, you are just doing the one thing to undo whatever operation is happening alongside the variable. Now, it's always a good idea to check your work or check your answer just to make sure everything works out just fine. You're welcome to just plug it back into a calculator if you want to. This kind of goes back to the evaluating expressions that we did a couple of weeks ago. So if we check this real quick, if we're saying that m is equal to -2, we're going to say -2 plus 12 equals 10. We'll just kind of ask that question there. If that's true, then we're like, yeah, okay, we're good to go. And it is. -2 plus 12 is 10. So we end up with 10 on both sides. 10 is equal to 10. That's exactly what we were looking for. So the value of m that makes this equation true is -2 for m. So there are going to be 4, maybe even 5 different ways that we can solve. There will be 5. 5 different ways that we can solve one-step equations. We're looking at 1- and 2-step equations today. So that's our first one right there. Now the second one, our variable is on the right-hand side of the equation, and there's nothing wrong with that. It's fine having it on the right-hand side. We just need to focus over here to get the value of g by itself. So if we're focusing on the right-hand side, g is being subtracted by 9. So we have to undo that subtraction. The opposite of subtracting would be adding. So we're going to add 9 to the right-hand side of the equation. And if we add 9 to the right-hand side of the equation, we also have to add 9 to the left-hand side of the equation because with our balance, we have to keep things balanced on both sides. If we didn't add 9 over here, this would no longer be an equation because we wouldn't have the exact same thing. Now, adding 9 to a minus 9 means that these two 9s cancel out completely, which leaves us with our variable g, which is exactly what we wanted. And then what does negative 2 plus 9 equal? Positive 7. Good. So g is equal to 7. That's what we're saying. If we do a quick check on this, we would say negative 2. I put the question mark above the equal sign because we're asking this question, is negative 2 equal to 7 minus 9? And yeah, it is, because 7 minus 9 gets us to negatives, and so it checks out. We're good to go. All right, so that's it for the first two. On the third one, problem number 3 here, we have negative 7y equals negative 91. What does negative 7y mean? What's that? Multiplication, exactly. Negative 7y means negative 7 times y. What is the opposite of multiplying? Dividing, yes. And in algebra, I've mentioned this multiple times. When we show division in algebra, we don't use the division symbol. We use what? A fraction. And so it's a little bit easier to use the fraction sign, especially when you're dealing with equations, because we always work equations from top to bottom. Format-wise, this is how I want you to do your equations. I want you to work from top to bottom. I would recommend writing the line down the middle or drawing the line down the middle. You don't have to do that, but it makes it, I think, easier to see what's on the left side of the equation, what's on the right side. It just keeps your work so much more organized when you're working from top to bottom on equation solving. So whenever you're solving equations, I want to make sure that you are working through those from top to bottom. So as we're working here from top to bottom, showing the division is going to be easier to show it using a fraction bar. So I'm going to say over here, because it's being multiplied by negative 7, we need to undo that multiplication. So we're going to do the opposite of that, which is to divide by negative 7. And negative 7 divided by negative 7 is positive 1. And 1 times y is just equal to y. So when we divide by the same number on both sides, the negative 7s cancel out on the left, leaving us with our variable, which is exactly what we wanted. And then on the right-hand side, we have a negative 91 divided by a negative 7. Negative divided by a negative is always a positive. And 91 divided by 7, I think, is 13. Yep, so positive 13 for y. Now, if you want to, in terms of checking your work, you're welcome just to go back here and use your calculator. You don't have to write out the check step if you don't want to. So if I type in negative 7 times 13, that's the work that's going on here because we're saying y is 13. We get negative 91, which is exactly what it was. So you can check your work on a calculator just to verify it, but I would always recommend checking it because this verifies that your answer was correct. And if you have a way to verify that your answer is exactly right, why wouldn't you do that? I would absolutely say every single time, double check to make sure you did it right. Go back, plug it in, see if it works. If it works, that means you did it correctly. If it doesn't work, then maybe go back through and see if there was an error somewhere along the way. So always check your answer on it because you can. If you can check your answer, it's a great thing to do. All right, number 4. We have a over 9. That means a divided by 9 equals negative 4. So this time, our variable is being divided. And if it's being divided, we have to undo the division by multiplying. So the opposite of division is multiplication. It was being divided by 9. So we're going to multiply both sides by 9. Multiplication is the one thing where we don't show the operation underneath. We subtract it underneath here. We add it underneath here. We divide it underneath here. With multiplication, we're going to multiply it to the sides. So I'm going to write times 9 there, and then times 9 over here. And 9 times a over 9 would be the same thing as this negative 7y over negative 7. This would be 9a over 9, meaning the 9s cancel out. These are all one-step equations, so these can be solved by just doing one operation to get the variable by itself. So on the right-hand side, we're multiplying by 9 because we have to do the same thing on both sides. -4 times 9 is what? What do we get? -36. So A equals -36. And then if you want to, or actually not if you want to, but then plug it back in, you can write it down if you want to, but definitely check your answer. Does -36 divided by 9 equal -4? Yeah, it does. So those are our four single operations to solve our one-step equations. However, there is a fifth way. There is a fifth way to solve a one-step equation. We've got our subtraction, our addition, our division, and our multiplication. The fifth way is to solve when there's a fraction multiplying by your variable. Does anybody know what to do with this? Has anybody ever seen this before? All right, so let's go back to 3 and 4 real quick. With the division, we divided by the same number because we wanted the value that's being multiplied by y not equal to -7, but equal to what? What happens when we divided -7 by -7? What number does that equal? 1, yeah. We want 1 multiplying by our variable when we're dealing with multiplication or division for that matter, because 9 divided by 9 is 1. So basically what we're looking for here on number 5 is we want to get this 2/3 basically to equal 1 next to this variable, because if it equals 1, that means it's just the variable. So over here on to the side, it says to get rid of a fraction, we're going to multiply. So we know we're going to multiply. What would you have to multiply 2/3 by to equal 1? I'm going to go back to our properties of real numbers real quick that we did a little while ago. And I'm going to point out the inverse property real quick as well. And if we look at this multiplication, if we look at the multiplication here for the inverse property, the result is 1, which is what we're looking for here. So it says using the opposite to cancel the value to get the identity value. So we want the identity value of multiplication, which is equal to 1. What do we multiply by in order to make that happen? In this case, it's kind of the denominator. In this case here, it's not quite the denominator. I mean, it uses the denominator for sure. We would definitely multiply, and 3 would be our numerator with this fraction here. But if we multiply by 3, then that would be 3 times 2 on the numerator, which would be 6. We'd still have 3 on the denominator. What do we have to multiply the denominator by to get to the same value as the numerator? 3 times 2 is 6. We want both of them to equal 6. So what would we have to multiply on the bottom? 2. 3 over 2. Because 3 times 2 is 6. 2 times 3 is 6. 6 over 6 is 1. Which means that these are going to cancel. 3s will cancel. 2s will cancel. And that actually goes away completely because now we have that value of 1 that we were looking for, which means that on the left-hand side of the equation is just x. We'll finish this up in just a second. But does anybody remember what it's called when you flip a fraction over? Reciprocal, yes. So to get rid of a fraction, multiply by the reciprocal. Flip the fraction over and multiply by that value. Now over here, we have to do the same thing. We multiply by 3 over 2 on the left. We're going to multiply by 3 over 2 on the right. And just as a reminder, when you have a whole number multiplying by a fraction, you can put the whole number over 1. Just to remind yourself that there is a denominator there with a whole number, and the denominator is always 1 when you have a whole number. 10 times 3 is 30. 1 times 2 is 2. 30 divided by 2 equals what? 30 divided by 2. 15. So x equals 15. So with multiplication of fractions, you multiply straight across and then divide. X equals 15. So 2/3 times 15. Let's find out. So I'm going to open up a fraction. I'm going to say 2/3 times 15. And there's the answer, 10. That's exactly what we were going for. All right, let's try this next one. 4/9 times W equals -8. What do we need to do? What's the one step that has to happen on number 6? What's that? Multiply? What are we multiplying by? The reciprocal. What's the reciprocal of 4/9? 9/4. So we're going to multiply both sides by 9/4. So whatever fraction is multiplying by the variable, flip it over, multiply both sides by that value. So 9/4 and 9/4. So on the left-hand side, cross cancel the 9s, cross cancel the 4s. All you have left is W. On the right-hand side, we've got -8 times 9/4. And again, you're more than welcome to use a calculator for this. -18. That's our answer. So W is equal to -18 for number 6. All right. How about number 7? What has to happen on number 7 to get K by itself? Multiply both sides by what? -5/6. Good. So when you multiply by the reciprocal, if it's positive to begin with, you keep it positive like we did on 5 and 6. If it's negative to begin with, the reciprocal of that value is still negative. So you're not going to multiply by +5/6. You're going to multiply by -5/6. And so the 5s cancel, the 6s cancel, the negatives cancel, and we're left with K on the left-hand side. And then on the right-hand side, we're multiplying 12 by -5, and then dividing that by 1 times 6, which is 6. 12 times -5 is -60. -60 divided by 6 is -10. So K equals -10. Check that on your calculator, it checks out. All right, try number 8 on your own. I'm going to give you about, I don't know, till about 40 seconds to do this one. Number 8, get that one answered and we'll get this figured out. All right, anybody have an answer? What's that? 18, nice. M is equal to 18, excellent. On this one here, we have -1/2. We're going to flip it over, multiply by the reciprocal. That's -2/1. The other way of saying -2/1 is just -2, right? So over here, because -9 is a whole number, I'm just going to write times -2. Because if the denominator is 1, that means it could be written as a whole number. And since this is a whole number, I'm just going to multiply a couple of integer values together. On the left, all the fraction stuff cancels. We're left with M. -9 times -2 is +18. Nice. All right. So that is our reminder on solving one-step equations. Now we're going to move on to two-step equations. So two-step equations are basically, they're just going to involve putting two of these things together in the same problem. Now, if we look at the directions, it says to solve a two-step equation, step number one, undo the addition and subtraction to remove the constant term. Remember that constant term just means the regular number that's by itself, the one that doesn't have a variable. So 8 would be the constant term here, -5, 9, 7. Those are the constant terms on those four problems. And then it says undo the multiplication or division in order to remove the coefficient. The coefficient is the number that is next to the variable. So 6, 2, -4, -3. Those would be the coefficients in these problems. What do you notice about the order that these are done in? Addition and subtraction, getting rid of those first, and then getting rid of the multiplication and division. What do you notice about that, Elijah? Oh, yeah, go ahead. It's like PEMDAS, but yeah, but we're doing it in reverse, right? Because order of operations would say that we have to do the multiplication and division first, and then the addition and subtraction. But if we think about equations, we're undoing things, right? So if we're undoing the order of operations, the first thing that we would do, in most cases, not every single time, but most of the time, the first thing that we would do is get rid of the addition and subtraction. And then we get rid of the multiplication and division. We're basically undoing the order of operations by moving through them backwards, because we're trying to get to this thing here that is being multiplied by 6 and then added to by 8. And so if we're trying to like unpack that and get to it, we're undoing that process in order to figure out what x is equal to. It's like moving forwards and backwards through the same process. So let's go ahead and take a look here. So problem number 9, it says the first thing we need to do is to undo the addition or the subtraction. And when it means that, it always means from the side with the variable. Okay, so the constant term that's on the side with the variable is this +8, this +8. So we want to undo the +8. The opposite of adding 8 would be subtracting 8. So we're going to undo the addition first by subtracting the same thing from both sides. So the 8's cancel out here, and we have 6x on the left. So we bring down the 6x. 50 minus 8 is 42. So now we have a one-step equation that looks a lot like number 3 did back up here. And when we take a look at the answer to this one, or when we finish working through this, 6 is multiplying by the variable. So we have to undo the multiplication by dividing both sides by that number, divide by 6. On the left-hand side, our 6's cancel out. And 40 divided by 6 means that x is equal to 7. All right. And then double checking that is going to be pretty easy. Take your 7, plug it in for 6, and then add 8. So if we think about plugging in 7 for x, 6 times 7 is 42. 42 plus 8 is equal to 50. So that checks out. And you can do a mental math check, you can use a calculator check, you can write it out, but you should always be checking your answer just to make sure that it works with the original equation up top, whatever you get for your variable. All right, let's try number 10 here. So 2 times n minus 5 equals 11. So step 1, undo the addition or the subtraction first. So we have a -5 here with the on the same side as the variable. So we have to undo the -5. Opposite of subtracting 5 would be adding 5. So we're going to add 5 to both sides. Notice that when I'm adding or subtracting, I'm always putting that number underneath the constant term on the side with the variable. It's always going underneath the regular number. It's never going to go underneath the term with the variable, because adding and subtracting a variable term with a regular number term, we can't do that because they're not like terms. But a regular number and a regular number, we can always work with. So on the left-hand side, -5, +5, those cancel out. Those are gone now. So the 2n is what's left over. So I'm going to bring that down. 2n, 11 plus 5 is 16. So 2 times n is equal to 16. Yeah. Okay. So we have to undo the multiplication now. And it says times 2. So we're going to undo the multiplication by dividing both sides by that value of 2. On the left-hand side, the 2's cancel. And we're left with n. 16 divided by 2 gives us our answer, n equals 8. All right, try the next two on your own, 11 and 12. See what you can do with those. Start with the addition and the subtraction, and then finish up with the multiplication or the division. On number 11, just make sure that you're dealing with getting rid of the stuff on the right-hand side because that's where the variable is this time. And on number 12, make sure you get rid of the regular number first. And just so you're aware, that 7 is a positive 7. That is not a -7, that is a positive 7. The 3 is the one with the negative. So when you're adding or subtracting on your first step on number 12, just know that that 7 is a positive number. So I'll give you a couple minutes on that. If you have questions as you're working through this, let me know. Look at it. Let's take a look at 11 here. So number 11, we're going to start by subtracting 9 from both sides. 9's cancel out on the right. We're left with -4k. 13 minus 9 is 4. Then we have to undo this multiplication of -4 with the variable. So we divide both sides by -4. On the right-hand side, they cancel out, and we're left with k. And then on the left-hand side, 4 divided by -4 is -1. So k equals -1 for number 11. How about number 12? What do we think? Anybody have an answer for number 12? Gabrielle, what'd you get? What's -9, Justin? -9. Ryder's nodding as well, -9. Good, I agree actually, which is a good thing. So over here on for number 12, This 7, as I mentioned, is a positive 7. So we have to get rid of that 7 by subtracting it from both sides. That negative is with the 3y. So when we get rid of this 7 on the left-hand side, when we remove that by subtracting it out, we're still left with a negative 3y. This is something that's going to be really important as we work through these, is that if you get rid of something and there's a negative after it, that means that negative is with the next thing. This negative is with the 3y. So when we bring this down, what's left over, we still have a negative 3y. And then 34 minus 7 is 27. So negative 3y is equal to 27. And so y is being multiplied by a negative 3. So we're going to undo that multiplication by dividing both sides by negative 3. And then 27 divided by 3 means that y is equal to negative 9. Nice. Are there any questions here? Because equation solving, by the way, equation solving is one of those skills with algebra that you will use this year. You will use it next year. You will use it the year after. Any math class that you take from here on out is going to be using equation solving. Any class that you take is going to be using combining like terms, distributive property, order of operations. Basically, all the stuff that we have done up until this point in the year is going to be used over and over and over and over again this year and every other year that you take a math class. So if you have confusion about what we're doing with this right now, or any of the things that we've done before with order of operations or integer operations or combining like terms or any of that, please stop by for TAT so I can help you out with that, because if you're struggling with that now, it's not going to get any better unless you come in and do some practice and get some help to work out some of those misunderstandings. So let's go and take a look at the second page. Turn the page. Now, when you're solving equations, I know we saw that the two steps here for the directions, step 1 and step 2. That's going to be true for most two-step equations. It'll be true for the next 6 of them. But when it comes down to it, like I mentioned, solving equations is basically working backwards through order of operations. Now, in most cases with two-step equations, that means you're going to be adding and subtracting first, multiplying or dividing second to solve. That's not always the case. Like I said, it is for the next 6 here. But for the 4 at the bottom, I want us to think more about order of operations when we get to 19 through 22 than add, subtract, and then multiply, divide. So number 13. What's the first thing we're going to do? Add 7. Good. So we're going to add 7. We still have the x divided by 2. 9 plus 7 is equal to 16. So we have x divided by 2 equals 16. X is being divided, so we have to undo the division by doing what? Multiplying. So we're going to multiply both sides by the same number x is being divided by. That would be 2. 2's cancel on the left. We're left with x. 16 times 2 equals what? 32. Good. So that's it for number 13. For 14, variables on the right-hand side of the equation this time. So we just got to make sure that we're looking at the right-hand side in order to figure out what needs to happen. So first thing here, what are we going to do on number 11? Subtract 8. So if we subtract 8, 8's will cancel on the right, which means we still have a c divided by negative 5. 11 minus 8 is 3. All right, what happens next? Multiply by negative 5, yeah. C is being divided by negative 5. We have to undo that division by multiplying by the same thing. So negative 5's cancel out on the right-hand side. We're left with our variable on the right, c. Negative 5 times 3 is negative 15. So c is equal to negative 15. That's it for problem number 14. These next 4, the first step is going to be very similar to what we've done. The second step is going to be going back to the fractions. because every single one of these next four are variables being multiplied by a fraction. So we have to undo that by multiplying by the reciprocal like we did a little bit earlier. So starting with number 15 here. What's the first thing we're going to do? What is it? Subtract 22. Good. So we undo the addition or the subtraction. So we're undoing the addition by subtracting. We still have 3/5 times x. On the left side of the equation, 28 minus 22 is 6. All right. We have a fraction multiplied by our variable. How do we get rid of that? What do we do to undo that? Saw this on the first page. What is it that needs to happen? Go ahead, help. Multiply by 5/3. Good. We multiply by the reciprocal of the fraction. That's multiplying by the variable. So flip the fraction over, 5/3. Multiply both sides by that. If you want to, you can make that 6 a whole number by putting it over 1. Everything cross cancels on the left-hand side, which is exactly what we wanted. Because that gets x by itself. 6 times 5 is 30. 1 times 3 is 3. 30 divided by 3 is 10. And again, you're welcome to use a calculator. 6 times 5/3 should be 10. That's what we end up with there for number 15. 16. What's the first thing that needs to happen? What is it? Subtract 1. We still have negative 1/3 times m. Over here, be careful. Negative 7 minus 1. Again, if you need to use a calculator for your integer operations, please do that. Negative 7 minus 1. It's not negative 6. It's not positive 6. It's negative 8. Negative 7 minus 1 is negative 8. Now to get the variable by itself, we have to undo the multiplication of that fraction by multiplying both sides by the reciprocal, which would be negative 3 over 1. Negative 3 over 1 is also just negative 3 as a whole number. So over here, I'm just going to multiply by negative 3. Because negative 8 is also a whole number. We've got m, negative times a negative, 8 times 3 would be a positive 24. So m equals 24. Couple more, and then we're going to look at these bottom ones where it says, watch out. All right, number 17. What's the first thing on this one? What do we have to do first on number 17? Add 10, good. The number with the variable is being multiplied here, so we're not going to do anything with that yet. It's a positive 7 force multiplying by the variable, but the addition or subtraction part comes over here. That's a negative 10. So if we're going to undo a negative 10, we have to add 10 to both sides. And again, be really careful here with this negative 38 plus 10. If it's not something that you feel confident about using mental math for, use a calculator. What is negative 38 plus 10? Negative 28, good. All right, last step here, multiply both sides by the reciprocal. So turn the fraction over, you get 4/7. That's what we're multiplying both sides of this equation by. 4s and 7s cross cancel on the left, leaving us with our variable. And then over here, we could do cross canceling as well. You're welcome to use a calculator if you want to. But if I were to cross cancel here, 7 can turn into a 1 because negative 28 divided by 7 is negative 4. And negative 4 times positive 4 is negative 16. Or if you want to, you can take negative 28. You can multiply that by 4/7. And there it is, negative 16. So either way, you're welcome to use a calculator on these. That can speed up the process. It can also help accuracy if you're not super confident about the facts. All right, last one of these type right here. So number 18, first thing we need to do is what? Subtract 9, good, because that is a positive 9, that is not a negative 9. The negative is with the 1/2, excellent. So we're gonna subtract 9, and that'll give us 6. And this is a negative 1/2 that we're bringing down, negative 1/2 x. Multiply both sides by the reciprocal of negative 1/2, so flip it over, that would be times negative 2/1. And over here, I'm just gonna multiply by negative 2, because negative 2/1 is a whole number, and since that's a whole number 6, I'm not gonna write the fraction form of it. All the numbers cross cancel on the right, leaving us with the variable x, and negative 2 times 6 gives us a value of x equal to negative 12. All right, so that's a pretty quick recap summary of 1- and 2-step equations. There are a few more down here that I want to talk about. Now, if we were using order of operations, if we knew what x was, what would we do first? What would we do first if we knew what x was? We would add 11, right? Because when we're talking about order of operations and you have a numerator and a denominator, if there's something operationally on a numerator like plus, that means it's a group. So you'd have to do the addition first and then divide by 8. So if you're working forwards through this process, you would add 11 and then divide by 8. Which doesn't sound like order of operations, right? Add and then divide, but it is order of operations because this is a group. Groups first, then exponents and multiplication, division, adding, subtracting. So in order to work backwards through order of operations on this particular problem, we would undo the division first because that's the last thing that would happen if we were using order of operations. Does that kind of make sense? So we're basically going backwards through order of operations. And order of operations says that in this case, we would have to add first and then divide. So we're going to undo the division first by doing what? Multiplying. We undo the division by multiplying. We're going to multiply by 8 on both sides. So this says the examples below are different in that the multiplication and division is done first. And the reason for that has to do with order of operations and moving backwards through order of operations. So on the left-hand side, the 8 on the over here cancels out with the 8 as the denominator. So the 8s cancel each other out, which means we're left with just the x plus 11. And negative 3 times 8 is negative 24. So now we have x plus 11 equals negative 24. And to get rid of that, to get rid of a positive 11, we just have to subtract it from both sides. And again, be really careful with these ones here. Negative 24 minus 11. Use a calculator if you need to. It's going to give us negative 35. So based on that, what do we have to do first on number 20? Multiply by negative 2. Good. So if we multiply by negative 2 first on number 20, that means we're left with n minus 5 equals positive 14. So basically, we have to get the group by itself first and then undo what's happening in that group. So last step here, add 5. These are still 2-step equations. It's just we're doing the multiplication and the division first now, because if we were to work through these using order of operations, we would have to add first and then divide, or subtract first and then divide. So we have to undo those order of operations. All right, try these last two on your own, 21 and 22, see what you get. And then after that, you'll get your assignment. You'll have a little bit of time to work, and I'll show you your quizzes as well. I said I would do that. So I'll get your quizzes back to you so you can see those. And if you have questions on those, you can ask as well. By the way, tomorrow is going to be another day on this stuff here. We're checking 2 days on 1 and 2 step equations. So if you have questions tomorrow on the assignment, please ask as many questions as you need on that.